Hello, everyone. It is Wednesday, the 29th of May, 2024, and I already did a video this morning, but it was regarding Helen Bruce and the court case that is still ongoing, and so I didn't want to mix that up with flat Earth stuff or possible true Earth stuff or Earth not being a globe stuff, or at least with not what's being prevented to us from the globe Earth proponents. Anyways, before I get into that, the Stu Peters network, I believe it's on that network, that Old World Order is going to be finally playing today. It was supposed to play on the 25th of May, but of course there were I guess like account hacks. I don't know, and servers down and system failures and all this stuff. So today is the day apparently that it's going to be out and released. It is a little delayed. I am excited about it. I've shared videos and data on Old World stuff now for years as well, and so this definitely is going to be something that is incredible. It's going to be a great video, and it's going to wake a lot of people up. I'm hoping. New word. I'm hoping. And yes, I don't even know where to start. I could start with Ewaranon and in his video. He has great work. And so I just wanted to talk about that first. Helen Bruce case still ongoing. I just did a video about that, and I hope that people do take a look at that. And then with Sean Hibbler Productions with Old World Order, there's a lot of great people that are in that video, so I really highly recommend people watch that today. And just before I get into this video, and I think I'm going to leave it at that before I get into it. I don't know how long this is going to be. Excuse me. This is from Flat Earth Sun, Moon, and Zodiac Clock app. It was posted 2 years ago. But again, it's coming up again. It's a lot more popular now. So maybe this is the time to reshare.
Hiding behind you, or your shadow at evening, rising to meet you. The Lord is my
I've shared this before for years, just so you guys know.
shepherd, I shall not want. He maketh me to lie down in green pastures. He leadeth me beside the still waters. He restoreth my soul. He leadeth me in paths of righteousness for his name's sake. Though I walk through the valley of the shadow of death, I will fear no evil. I will show you fear in a handful of dust. What are the roots that clutch? What branches grow out of this stony rubbish? Son of man, you cannot say or guess, for you know only a heap of broken images, where the sun beats and the dead tree gives no shelter, the cricket no relief, and the dry stone no sound of water. Only there is shadow under this red rock. Come in under the shadow of this red rock, and I will show you something different from either your shadow at morning striding behind you, or your shadow at evening rising to meet you. I will show you fear in a handful of dust. I will fear no evil, for thou art with me. Thy rod and thy staff, they comfort me. Thou preparest a table before me in the presence of mine enemies. Thou anointest my head with oil. My cup runneth over. Surely goodness and mercy shall follow me all the days of my life, and I will dwell in the house of the Lord forever. Ah, there you are. Good morning. We're still here stranded, but at least now the sun is rising. I'm hoping our vessel will be fixed very soon. But while we are still stranded, it's a good time to talk about this key I hold. This key is a kind of master key. And as we continue in our search for the rest and attempt to unlock certain doors, we will also use this master key to enrich our understanding of certain matters. As you will soon see, this master key unites many of the topics and matters of our concern, primarily the matter of lost time and history, of old world architecture, of our lost cosmology, and of the energetics of the world we live in. Our master key is
this master key, like this actual key, I actually, when I was on one of my road trips to Gaspé, I found a key like this a couple of years ago, and I kept it. And yeah, so just it's just interesting.
Complex and holds a wealth of information. We will not be discussing all it has to offer now, but rather just a small fraction of its secrets. I'm hoping what we will discuss now will prepare us well for the first door. But as we continue, we will often need to set aside further time to investigate our master key in more detail, especially in light of new information. Let's crack on.
Okay, I had to show it, obviously. It's, oh, can you see that? Yep, so I found that on the ground. It's metal. Very hard. What's it to? What is this to? Okay, bye.
It is no great secret that the two primary luminaries above our heads, the sun and the moon, function as timekeeping instruments. Time, as we know it, comes from our sun and moon. The sun rises in the east each morning and sets in the west each evening. From its rising in the east on the previous morning, it takes 24 hours for it to rise again in the east the following morning. Everyone knows that 1 whole minute is 60 seconds, and that 60 minutes make an hour, and that after 24 hours each day ends and another begins. And this is represented by our clocks. Looking at a clock, it is almost impossible to state when time actually began. It could have started at any hour. The hands of the clock continue to run in a cyclical manner day after day, year after year. And we all know that there are 12 months in a year, and that every 3 months, every quarter of a year, the Earth transitions from one season to another. Life on Earth begins and renews itself in the spring. The plants on Earth capture our seasons perfectly. They grow in the spring, flourish in the summer, begin to wither and wilt in the autumn, and come winter, the trees are barren. But as we enter spring again, a new year, the plants begin to grow again. Just like the hands of the clock, life continues. It renews and keeps going in a cyclical manner. The great circle of life. All circles have 360 degrees. The diameter of every circle is proportional to the radius. The traditional clock face is a circle of 360 degrees. And in watching the moon, we see the moon takes on a similar pattern as the seasons. Each month begins with a new moon. And as the month progresses, the moon waxes or grows into a crescent, then a quarter, then a gibbous, until it finally reaches a full moon. And then as the month continues into its second half, the moon begins to wane, back through a gibbous, a quarter, and a crescent until old. And then the whole process begins again. What the sun and seasons do over the course of a year, the moon does every month, like clockwork. And we live inside of this clockwork. We live inside of God's clock. But in case you hadn't noticed, this clock doesn't run as smoothly as one would expect. God made everything in perfect measure, but for some reason, he assigned 29.53059 days for the moon to complete its phases and 365.2422 days for the sun to journey from one vernal or spring equinox to another. Not only do these figures resist the tidy 360, the degrees of the circle, but they actually resist providing a convenient whole number for us. How can you have 0.2422 of a day and 0.53059 of a month? And this has proven problematic for pretty much all cultures when trying to establish their calendars. To reconcile a proper calendar in the seasonal cycle, the sun cycle must be manipulated to make that extra 0.2422 into a whole number. Adding a day every 4 years almost gets you there, but this then changes the average length of the calendar year over the course of 4 years to 365.25. If we subtract the solar year with this average calendar year, then we can see that it still overshoots the year by 0.0078 days, or 11 minutes and 14 seconds. 0.0078 days needs to be rounded up to 0.0080 or down to 0.0075. There is always a remainder. To reconcile this issue, those in charge of establishing official calendars employ intercalation. Intercalation in timekeeping is the insertion of a leap day, week, or month into some calendar years to make the calendar follow the seasons or moon phases. In the solar calendars, this is done by adding an extra day to the calendar every 4 years, and we call this a leap year. It's not spot on, but it's close enough. The lunar calendars, in their most common form, intercalate an extra day in the final month of the year 11 times over the course of 30 years. In calendar systems that use both the sun and the moon, or what is termed the lunar solar calendar, an extra 13th month or leap month is added every second or third year. It's all very complicated, and trying to dissect the way our calendars have transformed, manipulated, and misplaced time throughout history induces a swift and sharp headache. Because of the multitude of different calendars established throughout time by diverse cultures, and because ultimately our very own luminaries resist upholding tidy timekeeping behaviors, tracing time back through the calendar is an almost impossible task. If meaning, in the form of writing, is vulnerable to being lost in translation, then recorded time suffers the same susceptibility of being lost in intercalation. How to tell how much time has actually passed if the sun and moon, who inspired the very act of timekeeping in the first place, do not keep tidy time themselves? And this is what is of concern now. Why do our luminaries, primarily our sun, not behave in the way we would like them to behave in respect to time? At the end of Volume 1, the moon emerged as an unlikely but central character in our story. But it's now time to turn to another central character, that of the sun, whose importance is, in many ways, even greater. The sun is our master key. In 1999, J.L. Heilbron, professor of the history of physics and astronomy at the University of California, published a very interesting book titled The Sun in the Church. Its primary argument or point of exploration is in dissecting the notion that the Roman Catholic Church gave more financial and social support to the study of astronomy for over 6 centuries. From the recovery of ancient learning during the late Middle Ages into the Enlightenment than any other and probably all other institutions. For prominent flat earthers, this statement would be of no surprise. Many have documented just how involved the church and Jesuits became in funding and shaping the heliocentric lie that has now come to have a firm hold over most of us since the beginning of our lives. To call Heilbron's book a riveting read would be a lie. It's just as much a headache as some of the topics it covers, primarily that of somersault mathematics that the Jesuit-funded astronomers formulated in trying to justify the so-called science behind the heliocentric model, and the multiple commissions of the church in trying to align Easter with the vernal or spring equinox. In Heilbron's book, we are given an insight into the competing world of astronomers who were all trying to please the church and keep their funding going steady. The tensions we see emerge between the astronomers and the church is that between promoting heliocentrism, which directly opposed the church's desire to keep the model of the universe a geocentric one. As you know, the heliocentric model places the sun in the center of the solar system, and all the planets revolve and orbit around it. In the geocentric model, the Earth is at the center of the whole system and stationary, while the sun and planets revolve and orbit around the Earth. And the geocentric model aligns more appropriately with the Bible. The tensions between the astronomers' push for heliocentrism and the church's desire to keep the Earth at the center of it all is a...
Yep. So I didn't want to do the whole thing again. This is a very interesting video. Actually, I'm going to go on Meridiana.
Called meridianas. They are a type of heliometer, an instrument for measuring the behavior of the sun. A meridiana is a meridian line that runs from south to north in a large dark space or building with a hole in its roof. It is primarily constructed to observe the position of the sun's noon image. Meridianas are a type of pinhole gnomon. In essence, a gnomon is a simple instrument, usually a stick in the ground, that allows the observer to track the direction and position of the shadows cast by the position of the sun in the sky. This is how sundials work, and in observing the shadows of a sundial, the observer can ascertain what time it is. Rather than a shadow, the pinhole meridiana casts a sunspot or sun image through its hole. This sunspot will fall somewhere on the meridian line, and the sunspot will travel up the meridian until the sun outside reaches the highest point in the sky. When the sun reaches its highest point in the sky, this is what we call its zenith. And when the sun is at its zenith, this is officially solar noon. As the year progresses through the seasons, the height of the sun's zenith at solar noon will change, and so will the position of the sunspot on the meridiana. Please note, I am using the term zenith here to describe the sun's highest point in the sky on any given day. I am not using it in the strict astronomical sense of the sun being 90 degrees above our head. We will get to that much later. The gnomon of Saint Sulpice in Paris is a very famous example of one of these instruments. Here we see the meridian line run across the floor of the church and up to an obelisk. They placed the obelisk here because the church was not long enough to contain the length of the path of the sunspots throughout the year. As you can see from the diagram here, in winter the sunspot will directly hit the obelisk. This is because in the northern hemisphere, during winter, the sun's zenith, its highest point at solar noon, is lower in the sky. As the year progresses through to spring, the sunspot will have tracked down from the obelisk and fall on the circle near the middle. This is the marker for the spring equinox. During the spring equinox, the sun's zenith is higher at solar noon than during the winter months. And as the summer begins, the sunspot will have journeyed all the way up to the start of the meridian line here. Solar noon during summer is when the sun reaches its highest point in the sky during its annual journey. As autumn begins, the sun's highest point becomes lower in apparent height, and the sunspot makes its way back to the circle here for the autumn equinox. Now that's great. The astronomers of the Middle Ages and all the way up until the 19th century got their kicks out of creating holes in wonderful structures so they could watch the sunspot dance back and forth throughout the year. But this is not what they were really up to. They were monitoring the position of the sunspot annually and tracking the way it deviated between annual equinoxes and solstices. And maybe you're starting to think, hang on a minute, maybe the narrative is all fake and our advanced historical ancestors, the ones who built these huge structures that acted as energy generators, also made them function as huge gnomons to trap the luminaries. It's a fancy thought, but not quite.
Energy, harnessing energy, frequencies, vibrations, all that stuff as well. It's going to be an old world order tonight. I'm excited, but anyway.
Establishing a meridiana was no easy feat. It often required astronomers to commission drastic reflooring of these structures in order to achieve a flat level. Giovanni Cassini's method of leveling the ground is an excellent example. As Hilbrun explains, Cassini dug a ditch along the calculated course of the line, placed a wooden canal in the ditch, and filled the canal with water to provide an accurate level. Ah, the irony. The leading historical figures of astronomy had to turn to the immutable and uncurvable nature of water to achieve an accurate level so they could track the movement of the sun. Did they know? Or were they just blinded by obsessively looking at the sun? The question we need to ask, however, is why were the astronomers between the 1500s and 1800s obsessively tracking the sun's position during the equinoxes and solstices?
And that was
our
pseudo-scientific revolution period as well. And so I was at Carleton University. I'm at my 4th year, science degree, by the way. It's on pause. It has been since like the time that I had to leave friggin' Stittsville, had to flee. I was so distracted, couldn't do it. Plus, I was sharing information with the professors and heads of departments about actual science, saying that like what they were trying to share as like the scientific revolution, it was literally getting taught in our science fucking classes. Like that, the 15 to 1800s was like the scientific revolution period. I'm like, oh my god, that is so the opposite of what happened. But anyways, oh my goodness. And so, and because I was not vaccinated, I couldn't even enter the campus. And so I would be calling and emailing, and I was being polite. I was being respectful. I was offering data, references, and then trying to articulate myself via email. It's harder, right, than in person. And anyway, and so if there's any academia institutions out there that would be willing to, give actual science degrees to actual scientists, and not these fucking pseudoscientists, please reach out. Don189 at protonmail.com. Again, that's Don, DAWN, 189 at protonmail.com.
Attention to what the sun above us is actually doing. And it's time to talk about the obliquity of the ecliptic and the precession of the equinoxes again. Now, I broadly introduced these concepts in our examination of the moon. What I now need you to do is forget everything we explored here and in this model that I presented. We will return to it much later, but for now, forget it. To understand a crucial aspect of our master key, I need to discuss these concepts first of all, and ironically, in heliocentric model terms, and then geocentric plane model terms, or what is referred to as the flat Earth model. What I am going to try and explain now is not hard to get your head around, but it is very complex, and I will try my best. As you know, in the heliocentric model, the Earth rotates on its axis, and in addition to doing this, it orbits the sun. One rotation on its axis is a day, roughly 24 hours, and one full orbit of the sun is a year, or 365.2422 days. Instead of the Earth's poles being situated upright on the globe, they are displaced at an angle of roughly 23.4 degrees. This is what we call the axial tilt. The Earth rotates on this axis. In the heliocentric model, the Earth's spin and orbit are not the only movements. There are also 3 Milankovitch cycles, named after the Serbian geophysicist and astronomer who theorized them, which describe the changes in the Earth's movement and the impact it has on seasonality and locality of solar energy. Accepted scientific theory posits that the Earth's axis is slowly changing. According to this theory, there are a handful of ways it is changing, and they are happening simultaneously and slowly. We have already spoken about one of these changes, the first Milankovitch cycle, that of the changing orientation of the Earth's rotational axes, or what is called the precession of the equinoxes. Because the Earth is apparently tilted and rotates, scientists have used the analogy of a spinning top to describe this kind of axial movement. Like a spinning top, Earth doesn't just rotate in a fixed-like manner at an angle of 23.4 degrees, but traces out a cone-like trajectory very slowly over time. Because of this cone-like trajectory, the designation of our pole star directly above our North Pole, which is currently Polaris, will slowly change. Due to this precession, our pole star 5,000 years ago was Tuban, in the constellation of Draco. In 13,000 years from now, our pole star will no longer be Polaris, but will point directly at Vega in the Lyra constellations. Another way this precession is observable is in the rest of the stars above us. If our rotational axis changes to point at a different pole star, then all the positions of the stars and constellations we witness above will have also changed. And, as we discussed, one of the main demonstrations of the stars drifting from their fixed positions is the precession of the equinoxes. This drift happens very slowly, at a rate of 1 degree every 72 years, an entire constellation every 2,160 years. We can observe this by tracking the sun's position on the equinox relative to the fixed stars beyond. The second Milankovitch cycle is much easier to grasp. It pertains to the shape of the Earth's orbital path around the Sun, or what is officially referred to as the eccentricity of the Earth's orbital cycle. The theory posits that the orbital shape of the Earth's path around the Sun fluctuates from circular to elliptical over a period of 100,000 years. As the theory states, these oscillations from circular to elliptical have a dramatic impact on glaciation, as they alter the distance of the Earth from the Sun, which therefore alters the amount of solar radiation that the Earth is exposed to. The eccentricity is affected by the gravitational attraction of the other planets, we are told, and is currently near its least elliptical, or most circular, and continues to decrease. The final Milankovitch cycle pertains to the shifting axial tilt of the Earth, or the shifting obliquity of its axes. Oblique is an adjective which means having a slanted or sloping direction, course or position, inclined, designating geometric lines or planes that are neither parallel or perpendicular. And in the heliocentric model, Earth's axis is indeed slanted. But in this model, we do not just live on a tilted and bloated spherical spinning top that is at once rotating and tracing out a cone-like trajectory, but its tilt also fluctuates. As you know, the current obliquity or tilt is 23.4 degrees, but this obliquity shifts and fluctuates between 21.1 and 24.5 degrees over a period of 41,000 years, we are told. And yet, despite all their models' complexity, we have yet to feel any motion in regard to the Earth. It is almost impossible to talk about the Sun's position in the sky as if we were orbiting the Sun. Try it yourselves. Sit in your gardens and parks and speak about the position of the Sun as if we were moving. It's morning and sunrise, which means we have spun half our cycle since yesterday evening. It feels weird to speak this way because it is unnatural. And this is because we do not feel any motion in regard to the Earth. What we actually perceive with our own eyes is the Sun changing its path in the sky throughout the year. So let's try and conceptualize what this obliquity of the ecliptic looks like here on Earth. And to do this, let's head over to the equator for the equinox. The Sun hasn't risen yet, so let's expand our viewpoint in anticipation. What we see here when looking out at this expanded viewpoint is what is termed the celestial sphere. It is an abstract concept and, in the spherical Earth model, surrounds a spinning ball. Now, we can divide this celestial screen in half, and this is what is known as a celestial equator. And just like the geographic equator divides the north and south of our so-called planets in half equally, the celestial equator divides the sky. We are on the geographical equator at 0 degrees latitude, so it divides our sky screen here equally. Ah, here comes the Sun. Watch closely. As you can see, when positioned on the equator during the equinox, the Sun reaches its true zenith, which means it is directly overhead at 90 degrees. As you can also see, the Sun travels the celestial equator here perfectly. It is currently 1 PM. It will continue to traverse the celestial equator until it sets. Now, let's rewind the Sun to 1 PM and see what happens as we progress through the months of the year, keeping our time fixed at 1 PM. As you can see, the Sun at 1 PM changes position. It weaves between the celestial equator like a serpent. As you can see, the celestial equator remains fixed here. But there is another line carrying the sun. This line is called the ecliptic. And as you can also see, the ecliptic has both northerly and southerly limitations. The sun does not track past this line to the north and this line to the south in its annual journey. These lines mark the tropic lines of latitude, Cancer and Capricorn, which form at 23.4 degrees north and south of the equator. If the ecliptic is the annual path of the sun, then the obliquity is the northern and southern limitations of this path. There is no 23.4 degrees tilt of the Earth, but the sun deviates 23.4 degrees either side of the celestial equator during its annual journey. I understand this is quite hard to visualize, so let's spend some more time on it. To conceptualize this, we will use 4 different points in the year: the equinoxes and the solstices. Here is the path of the sun throughout the day at the equator during the spring equinox. And now the summer solstice. And the autumn equinox. And finally the winter solstice. As you can see, there are 2 forms of motion here in regard to the sun. The first is a daily motion across the sky, and the second is the yearly drifting of this daily motion to the tropic lines of latitude and back. The annual drifting of the sun to the tropic lines is the obliquity of its path. Let's now relocate to 50 degrees latitude in the northern hemisphere and see what this looks like from this location. This is the spring equinox. And now the summer solstice. The autumn equinox. And finally, again, the winter solstice. While it appears that the sun's height is changing throughout the year, it is ultimately an optical illusion. For instance, during the solstices at 50 degrees latitude north, it appears that the sun is higher in summer and lower in winter. But if we change our perspective to face southwest and combine the 2 images, you can see the sun is not increasing and decreasing in height during its annual journey, but its location relative to the celestial equator changes. Therefore, it looks higher in the summer in the northern hemisphere as it is journeying the Tropic of Cancer, and therefore closer to those living in this location. And it looks lower in the winter as it journeys the Tropic of Capricorn as it is further away. There is a very profound paradox surrounding this, and we will explore it much later in our journey. But play around with vanishing point vectors and it may become apparent. In all its simplicity, the obliquity of the ecliptic is nothing more than the geographic limitations of the sun's annual pathway. And these limitations are located at 23.4 degrees north and south of the equator. And as you saw in this demonstration, the sun's annual journey across its ecliptic pathway forms like a serpent sine wave or energized helix. You can also see that at some point, the ecliptic line traverses the celestial equator. This occurs twice a year, and this is what we call the equinoxes. It is the meeting of 2 lines. And you can see here on the equinox, when the sun is at solar noon, that the cross these lines form visually represents the obliquity of the sun's path. There is a 23.4 degree difference between both the ecliptic pathway of the sun and the celestial equator. This is the obliquity of the ecliptic, or what the scientists have termed E. And it's because of the obliquity, because the sun drifts between the northern and southern tropics annually, that we have changing seasons. The heliocentric model posits that the obliquity of the sun's apparent pathway in the sky above us is due to the Earth's axial tilt. In this model, the seasons occur because of the tilt of the Earth. For instance, as the Earth journeys away from the spring equinox, the northern hemisphere tips more towards the sun due to the axial tilt. This means it is summer in the northern hemisphere. As the Earth rotates, the angle of its tilt changes, and therefore the seasons begin to change because of the variations in solar light and radiation hitting the northern and southern hemispheres. In the flat Earth model, it is the sun that is moving above us. This model attempts to capture the sun's path and its obliquity through the concept of a spiral coil. From the equator, the sun spirals inward until it reaches the Tropic of Cancer north at 23.4 degrees latitude. It then spirals outward back to the equator for the equinox, and then keeps going until reaching the Tropic of Capricorn south at 23.4 degrees latitude. And although this model's conception of the sun's annual pathway is not entirely accurate, it is accurate in its argument that it is the sun above us.
Oh my God, another good channel. Oh my goodness. I'm just getting this now. I'm so sorry. Oh my God, and it was like 20 minutes ago, almost. Oh my goodness. Anyways. Yeah, I'm just getting back on, so I don't even know if I'm still following
that is moving, and that its annual pathway deviates from the equator. To summarize then, the annual path of the sun does not continually traverse the celestial equator, but deviates north and south on its ecliptic line, reaching a maximum of 23.4 degrees latitude. And the angle, or degrees, between the ecliptic pathway and the celestial equator is what is termed as the obliquity of the ecliptic, or E. And in addition to the seasons, one of the key ways this obliquity and the second Milankovitch cycle of eccentricity affects our lives here on Earth is in the difference between the hands of the man-made clock and the actual behavior of the sun clock above us. Hilbrun's research demonstrates that both the church and the astronomers from the 16th century onwards were obsessed with monitoring the annual path of the sun and tracking any deviations that occurred each year. And they found that meridianas were a good way to do this. But the meridiana and the vast amount of sundials and other heliometers that were appearing in excess throughout European cities and towns up until the 19th century also provided a service to the locals. They were able to congregate around a sundial around local noon to reset their clocks. The locals could watch a shadow of the sundial approach noon and wind their clocks to make sure they were running on accurate time. But there was a problem. For you see, before the establishment of time zones and standardized time, noon happened at different times within the same country and even within the same city. As well as forming a reliance on town sundials, the locals also relied on church bells to chime at the right moment to ascertain the time and wind their clocks. But for those living in a city such as Rome, according to Hilbrun, it might take 20 minutes or more for all the churches in the city to ring in the same hour. The disparity in sounding the hours among church clocks throughout Europe, he continues, was notorious. And it was up to the individual to ensure they kept running on true time. As one Jesuit teaching manual from the time preached, the clocks almost never agree. You must overcome this defect by your diligence. And this disparity between the man-made clock and the actual sun clock above us presents itself because of the obliquity of the ecliptic and the sun's eccentricity. The reason for this is because our clocks make the intervals between each successive day equal to 24 hours. If it is noon on a Tuesday, then you can guarantee that in 24 hours time, your wristwatch will tell you it's noon on a Wednesday. Our clocks are regular and standardized. If you look at your wristwatch and see that it is 9 p.m. on a Friday, then you can feel reassured that 24 hours later, the hands will be striking 9 p.m. on Saturday. But the sun above us does not act in this regular and standardized manner. For instance, solar noon on the 7th of April occurred at 12:56 p.m., But a month later, on the 7th of May, it occurred 4 minutes earlier, at 12:52 p.m. If the sun only journeyed the celestial equator, like it does on the equinoxes, then the sun and the clock would align and solar noon would occur every day at the same time. But because of its obliquity, it slowly starts to fall out of sync with the man-made clock in its annual journey. And as the locals soon found out, the amount of discrepancy between their clocks and the actual time told by the shadows cast from the sun above changed from day to day. The fault was not only in the clock. No matter how accurate its movement, a clock made to tell equal hours throughout the year must disagree with the sun most of the time. And that was fine, as the locals ensured they kept their clocks aligned to the sun. But then another problem arose. As the locals became good at congregating around town sundials and making sure their watch time and the sun time aligned, they would notice that during 2 periods of the year, the shadows of the sundial would move faster and slower than the hands of their clocks. This is the effect of the second Milankovitch cycle, the sun's eccentricity. Because the sun's annual pathway between its tropic limitations is not a true circle, but is slightly elliptical, the sun moves a maximum of 14 minutes slower in February than a man-made clock, and moves at a maximum of around 16 minutes faster than the clock during November. Remember, on the 7th of April, solar noon occurred at 12:56 p.m, while on the 7th of November, it occurred at 11:40 a.m, a whole 16 minutes faster, including the hour for daylight saving. And that's because the sun's annual pathway between its tropic limitations is not a true circle, but is slightly elliptical, and therefore doesn't move with one regular speed, but speeds up and slows down during 2 times throughout the year. And if you combine both the effects of the obliquity and the eccentricity, you end up with a graph looking like this. The horizontal line here represents our man-made standardized clocks that bring in each new day with 24-hour-long intervals between successive days. But the positive and negative crests of the sine wave here represents the way the sun clock above us deviates from the man-made clock throughout the year. The positive is when the sun is faster than the clock, and the negative is when it is slower than the clock. And the difference between the sun's irregular behavior and the clock's regular tidy ticking is what is called the equation of time. If you were to set up a camera in the same spot and take a photograph of the sun throughout the year, ensuring that you took the photograph at the exact same clock time each day, you'd witness something very, very special. It's called the analemma. It is one of the most magnificent and mind-blowing phenomena related to the luminaries, and it captures the influence of the obliquity and the eccentricity of the sun's path perfectly. The shape of the analemma, the figure of 8 with uneven lobes, or some might even say the figure of a fish, is a celestial embodiment of the equation of time.
Analemma, the figure 8, this is the sun's path. Within the firmament above us, within the sky, on an annual basis.
If there were no obliquity and eccentricity, and the sun ran as our man-made clocks run,
every single year,
if each interval between successive solar noons was in fact 24 hours, then there would be no analemma throughout the year. The sun would appear at the same point in the sky at the same time of day throughout the year. The analemma would be a dot. If the sun's obliquity, its northern and southern drifting, was still present, but the eccentricity of the path was circular and not elliptical like it is today, then the analemma would be a symmetrical figure of 8, and its southern and northern lobes would be of equal size. And really, The easiest way to demonstrate just how much the obliquity of the ecliptic, the 23.4 degrees drifting of the sun in its annual path to the north and the south, affects our lives on Earth is to imagine if it didn't exist at all. Let's also imagine that the eccentricity was always circular. If we reduce the obliquity to 0 degrees so that the sun's path ran completely perpendicular to the celestial equator throughout the year, then not only would the sun keep tidy time and align with our clocks, but there would be no seasonal fluctuations, and day and night would be equal length, day in, day out, in, year out. And John Milton, in his epic poem Paradise Lost, theorized that the sun's path in the pre-fallen Edenic world had no obliquity. Some say he bid his angels turn askance, the poles of the earth twice 10 degrees and more from the sun's axle. They with labour pushed oblique the centric globe. But what would happen if the obliquity increased to 90 degrees? The limitations of the sun's path, the tropic lines of latitude, would then be relocated to here. And there would be a dramatic effect on seasonality. A lot of ice would melt, wouldn't you say? And here is where it gets very interesting. As Hilbrun's The Sun in the Church explores, the Jesuits and astronomers were not just flexing their mathematical prowess in trying to determine whether the Earth orbited the Sun or vice versa. They were obsessively checking whether the obliquity was shifting. As early as 2000 BC, different cultures were measuring the obliquity, we are told. And it was widely believed during the Middle Ages that the obliquity oscillated around a mean value. What does this mean? Since the Middle Ages, the 23.4 degrees has been, give or take, the accepted mean average. And Milankovitch later hypothesized that Earth's axial tilt varies over a 41,000 year period from 22.1 to 24.5 degrees. And like we just briefly demonstrated, if the angle of obliquity were to change, then both tropics would move in tandem. As you know, there are 5 prominent circles of latitude. We have the Arctic and Antarctic circles, the Tropic of Cancer and Capricorn, and in the middle we have the equator. These lines of latitude are what is known as parallels. They are bound by one another. If one were to move, then another line of latitude would also move in parallel. In the flat Earth model, this would mean these concentric spiral rings would begin to shift in parallel, either moving closer together or further apart. If the obliquity changed to 10 degrees, then they would shift closer to the equator. If the shift went to 60 degrees, then they would move further apart. In the less popular and underrated rectangular models of flat Earth, the same thing would happen. The tropic limitations would shift closer or further from the equator, and the Arctic and Antarctic lines would also be relocated. And you might want to ask, why did Milankovitch only hypothesize a shift in obliquity between 22.1 and 24.5 degrees? A shift of 1.1 degrees from 23.4 to 24.5 and 1.3 degrees from 23.4 to 22.1 seems, after all, quite a small fluctuation in the grand scheme of things. Why wouldn't the obliquity ever go back to 0 degrees or all the way to 90 degrees in their model? Before we theorize, let's quickly examine what Wikipedia tells us about this shift. As they state, the Tropic of Cancer is currently shifting southward at a rate of almost half an arcsecond of latitude, or 15 meters per year. As a result, approximately and on average, the tropical circles are drifting towards the equator and the polar circles toward the poles by 15 meters before turning and beginning to shift back the...
So I want to shift gears a little bit so that you can go on Dave's channel. I'm sure he's the one that's managing it, running it. I need to get my interview with him back up. So this is from Jeff. He calls himself Stinky Cash. because of the Federal Reserve and his take on that. And so if anyone's wondering why, he's actually very fucking smart and has great content. I shared his revolutionary video that shows in such a great way with representations, like visual representations, which really facilitate with learning information that you've not seen, or the information that not only have you not seen before, but you have not read about it or heard about it before, right? So there's no frame of reference, like I've talked about before with people, for people like myself and Jeff and Jaron and Dave Weiss and Mark Sargent and Eric Dubé and these others, to even articulate ourselves or explain theories and debunking what people are alleging to be laws of physics and laws of nature, because we don't have a frame of reference. And so anyway, and he's also very talented. He's also a musician. In this video, he's also he's playing a guitar and he's singing. So yeah, interesting.
Speed.
It's very interesting to me always that people that have higher level intellect always have some kind of a musical or artistic or creative component to them, to their lives as well, whether it be interest or actually like within the fields.
But what happens is, howdy, Michelle. Hello again, beautiful soul. So as you see, a solar day is only 4 minutes slower than a stellar day, a sidereal day. Sidereal means stars, stellar. Okay. So the stars are going to take 23 hours and 56 minutes to circle once, but the sun is going to be a little bit slower by only 4 minutes. So it's going to kind of appear that the stars and the sun are circling at the same speed, but the sun is just 4 minutes slower than the stars. Now, because the sun is 4 minutes slower than the stars, that 4 minutes is going to cause the sun to lose roughly 1 degree per day. 4 minutes equals 1 degree. You could do the math for yourself. So that 1 degree a day, with each rotation of the stars, the sun will lose 1 degree. And it will go from Taurus to Gemini to Cancer to Leo and so forth and so on. So a lunar day is 50 minutes slower than the sun. So while the sun is going to lose 1 degree per day and fall through the zodiac once a year, the moon is going to lose roughly 12 degrees per day and fall through the zodiac once a month. So the sun is going to traverse the zodiac once a year. The moon is going to traverse the zodiac once a month. They do the same pattern, but one is an annual body and one is a monthly body, right? The moon is the months, and we use the sun to tell us the years. We don't use the moon for the years. A lunar calendar is used by, as far as I know, the lunar calendar is used by witches and Jews. So
Gotcha.
we're going to try to steer clear of the witches and the Jews, and we're not going to use a lunar calendar. We're going to use a solar calendar.
He jokes a lot. This is sarcasm. And yeah, because there's also Asian countries that follow a lunar calendar, not a solar calendar. There's a lot of civilizations that it's not just Jew. Oh my God. And witches.
To keep track of the years. And as you see, when the moon crosses in front of the sun, that would be a new moon. Sometimes when it's perfect, it's an eclipse. Joyce B, hello, my friend. Welcome to the live stream. All right, so let's see if I could project this onto the TV. That would be pretty dope. Maybe if I don't know how to do that. Oh, well. All right. Let's move on to this document. Tony Dixon's here. What's up, brother? If you go down here, we'll take a look at these We're going to take a look at my iPad. And it says, mind you, these are the rambling notes of a madman from over 2 years ago. I don't know what's written in this note. I didn't review it before the live stream. We're doing this just like the last live stream. I'm going into this somewhat blind. This was written by me, former me, of like 2 years.
I haven't watched this video yet either.
Ago. So
I just watched like the first intro. So anyway.
I barely remember what's in this document, but we're going to go through it. And as you can see, let me see if I can study this. This is not a great way to do it, I admit. I wonder if I can get this to project onto the TV. That would be great. Let me see if I can figure out how to get this onto the TV. Wow, I even wrote a script. Holy mackerel. This document is full of sauce. Oh my God. Come on, screenshot. Damn it. Screenshot. Good. Okay. Screenshot. Now. Don't worry, guys. The sauce is coming. Who do you think you are? Ha ha ha. Bless your soul.
Let's see if you can do it. I'm just gonna maybe fast forward it.
Did I do it? Oh, yes, I did.
That was fast.
All right. So the first note on this is about Venus. And it says Venus. Oh, hold on. It's cut off the word Venus on the top. But it says Venus has a 1.6 degree shift per day around the sun. So this is what I'm trying to explain to everybody here. The sun circles the flat earth once a day, and it drags the planets with it. All the wandering stars are circling the sun as the sun circles the flat earth. Now, when it comes to Venus, Venus is going to circle the sun, and it's going to shift by 1.6 degrees per day. That 1.6 degrees, because look, Venus takes 225 days to complete one revolution around the sun. Now, 1.6 degrees per day times 365 days, you get 584 degrees around the sun per year. 584 days is known as a synodic period.
Yeah.
That's interesting. Now, you have to understand 1.6, that's the golden ratio. That's why Venus creates such beautiful symmetry. So Venus circles the sun.
It's like 1.618 or something. Anyways, golden. It's phi. He's talking about phi. I just was going to add some more things with Venus as well. I just want the numerical value. So yeah, so 1.618. I just want to confirm because there's so many numbers going on in my head right now. So he's right about the golden ratio, but it's not just 1.6, it's 1.618. And then it goes down. It's an irrational number. And so also with Venus, also known as Aphrodite, Lucifer, Hemera, Dawn, Aurora, Eos, Phosphorus, Vesperugo, etc. I've talked about this in many other videos as well. The greatest north latitude from the equatorial belt or ring that Venus travels is 9 degrees 2 minutes, which is a measurable distance. And south latitude might also 9 degrees 2 minutes. You've got that 9229 in there as well. Taurus and Libra are these zodiacal signs correlated with Venus. Venus rules over Taurus and Libra. The element correlated with Venus is copper. Oxidized is green. The color associated with Venus is green, which is when you look at the visible and non-visible light spectrum. But when you look at the visible light spectrum, the color in the center of that is green. And even on this flat plane of inertia, where I believe we're experiencing this cosmos on this flat plane of inertia. But again, like there's a hyperboloids and toroidal fields and all that stuff that create this electrical magnetic reality, which is light in motion that you need frequency for. But anyways, and we see more shades of green than any other color. And yeah, the day of the week associated with Venus is Friday, and the fourth chakra, which is the heart chakra. And I was going to say, even with like red and blue makes green, or red and violet make green. When you look at the like the visible light spectrum with the the extremes, you've got the red, and then you've got the 7 primary colors, or the 7 colors of the rainbow. When you go down the list, you got red on one end and you got violet on the top end, or however you want to look at it. Flip that upside down, and the center one being green. So when you combine those two, that would make those colors that would make green. And so why I'm saying that is with the heart, it's connected with the heart chakra. When you connect, when you have oxidized versus non-oxidized blood, you've got the red versus the blue blood within our own bodies, and that gets pumped within our hearts. And one section being 2 sections and the other one being 3. So you got the 2, 3 with that as well. You divide 2 by 3, it's 0.66. Anyway, I'm going on all these freaking tangents, but yeah, so you mix those colors and it makes green. And that's also why it's correlated with the heart chakra. Anyway, let him talk.
13 times for every 8 sun cycles. So in the course of 8 Earth years, over the course of 8 years, Venus will circle the sun 13 times. Notice how, again, that's the Fibonacci sequence. 1, 1, 2, 3, 5, 8, 13. 8 and 13, both numbers a part of the golden ratio, because 1.6, that is the golden ratio. So Venus returns to the same place in the sky after 8 years. It's 2,920 loops of the sun. It follows the golden ratio. So does that make any sense to people? As the sun circles the earth, as the sun circles the earth, Venus, let's say Venus is here, right on the bottom of the sun. Relative to the sun, it's perfectly straight downwards. It's going to circle with the sun once per day. And when it gets back to here, it will have shifted 1.6 degrees. Then the sun's going to make another circle. Now Venus is going to shift another 1.6 degrees. And after 225 circles of the sun, Venus will have made one entire revolution around the sun. And after 8 years, Venus will return to the same place in the sky. Okay? So Venus is very much tied with the golden ratio. Very much linked and tied to the golden ratio. Basically, somewhere in this note of mine, I'm trying to think, where did I write what I wrote? I wrote Tycho Brahe model multiplied by flat Earth equals golden sun spiral. So the Tychonian system was pretty close. Look, Mercury is no different than Venus. So I had all the math up here for Venus. Venus has a 1.6 degree shift around the sun per day. It takes 225 days for it to make 360 degrees around the sun. And after 8 years, it returns to the same place. makes one complete cycle, that flower of Venus. Mercury is similar, but Mercury is going to shift around the sun 4.09 degrees per day. So it takes Mercury 88 days. I'm very concerned about your starter. You shouldn't be. I fed my starter yesterday. I feed my starter even when I don't make bread. So some of the starter gets thrown away and wasted, but at least I fed the mother and kept the mother alive. So I have kept my mother alive. I just haven't baked any bread. Okay. Anyway.
Okay, so I don't know how long he's going to talk about Venus for, but since we're on that tangent, and then I'm probably going to let this go because I have to make banana bread today and brownies for people. Not that I have to, I want to. But just with the transit of Venus, because it's also very important that people understand that it's so hard to find this on online. And I'm trying to find the transit of Venus 2024 through the zodiacal belt or the zodiac signs. Maybe this will help, but because this is it's approximately 20 to 26 days or whatever. But anyways, look at this, because it's also predictable, also through the months and through the year. Let's see if it says it in here. Venus transit in Taurus. So Venus transits Taurus on May 19th, 2024. That's not what I want to know. Transit into Aries. Through, let's see, Sagittarius. It doesn't retrograde this year, but it will in March of next year, and it did anyway. The Venus transit in Sagittarius date was 18 January 2024. The transit of Venus from Scorpio to Sagittarius will take place on the 12th of February. Okay, and so it goes from Sagittarius to Scorpio, and that's in February. So I'm going to assume that in March it's going to be in after Scorpio, Sagittarius. So there's it going backwards. Let me see here, from Sagittarius to Scorpio. So Libra, possibly Libra. I don't know. Let's see here. No, Aquarius. Okay, so let's see here. So you're going from, why would it be Aquarius? It's really, well, I mean, they are close. Aquarius is close, actually. And I'll show you Stellarium, because they're all technically like really. And Virgo is like the largest of the images or zodiacal signs in the sky as well. So this could be misleading when you look at the actual. Anyway, okay, so March is April. Let's see what's after Aquarius then. Aquarius, Aries. April, May. So these are all predictable. Taurus. Okay, so we're getting somewhere here. June. Okay, we're getting somewhere here. Gemini. Okay, so I'm thinking possibly Cancer next. Nope, fucking Gemini. Oh, didn't they already say Gemini? No, I would have said Gemini after. Why would it be? No. Right now, Venus is in Gemini zodiac. Why would it be in Gemini and then Gemini again? So June. Okay, July. Maybe it's because it's at the end. Oh, and we'll move to Cancer. Okay, there you go. So Cancer. Okay, so I was right. I'm going to go from Cancer to Leo. Okay, let's see here. It should be friggin' Leo. Okay, Leo. Okay, so we're from July 20th to the 25th of August. Okay, so we might be looking at September. September would be Virgo. I think sometimes they mislead us and they actually say that like full moons and new moons and other periods are in between signs, and that's also to mislead us. And so like it could be like it could be like the sign before or after. But if you don't look at the actual calendar that it actually follows for the moon, then you wouldn't understand like what like every month when there's a full moon or a new moon. Like let's say it started like there was a full moon in Capricorn, then the following month it's Aquarius, and then it's Pisces, and then it's Aries. So we're starting the cycle over again, and then Taurus, then Gemini, then Cancer, then Leo, then Virgo, then Libra, then Scorpio, then Sagittarius, etc. Right? And so that's why with Venus it was throwing me off, because I think that's a way to I think Venus is actually in. They throw us off at the beginning so that you don't look at it for the whole friggin' thing. So let's see if September. This should be anyway. So tell me what it is. Okay, September. So tell me what it is. Virgo. Okay, so I was right. Okay, that already came up. Okay, so I'm good with that one as well. Okay, so September. So October, I'm going to assume after Virgo it would be Libra. Or it skipped again. I went from Libra right to Scorpio. So again, like I wouldn't necessarily, but they're close. That's why, right? Like you can get away with saying that because some of these zodiacal images or signs, whatever you want to call it, are very close together. Yeah, let me see here. Anyway, I'll keep the video playing. Very interesting stuff, though. But anyway, just to add more to Venus with that as well. And is there anything else I can say? It does. Oh yeah, and so through the zodiacal belt as well. That's also an important point. It does not travel more. Oh yeah, I already said that. Like more than the 9.2 degrees and minutes north and south latitude of the equatorial belt. Also very important. And like with its sun's like in relative to the sun's transit, and the sun not traveling more than 23.4 degrees north or south latitude from the equatorial ring. And then the luminaries or wandering stars, whatever you want to call it, they do travel quite close to the sun, and they do extend out a little bit, again, depending on the seasons. And if you had a farmer's almanac, you would know that, because the farmer's almanac also predict the like the transits and the movements of these 7 original wandering stars. So you do get it. I've already read this on my farmer's almanac. But for Venus, for Mars, for Jupiter, for the sun and the moon, Mercury, if I didn't already say that. Yeah. So these are predictable paths. And people like Copernicus and all these other geniuses alleged that could not happen. And consistently proven wrong, even on this video.
Mercury will do a 4-point, and take note.
Even the fact that we can predict any of the transits of Venus shows that they were incorrect, just to be clear. And then also with the moon, which we do, and which Jeff is doing as well.
Notes, guys. Take notes.
Fucking Copernicus.
Mercury will make a 4.09 degree shift per day around the sun. 88 days, 88 circles of the sun. Mercury will have made 360 degrees around the sun. So 4.09 shift times 365 equals 1,493 degrees around the sun. Because look, how many times, it's only 88 days long. How many times does 88 go into 365, right? Okay, so basically I wrote the Tycho Brahe model multiplied by the flat Earth model equals the golden sun spiral. It's this is the true system right here, guys. We don't have time for a meeting of the Globe Earth Society.
So 365 divided by 88, it's 4.1477272727.
Okay. The Ptolemy and the Potomac and Tychonian graphics are derivatives and not actual observations. They graph the relative shift of the heavenly bodies at the same time, night after night. They don't track the actual motions. Okay, it's similar in concept to the solar analemma. Okay, so let me see if I could get a visual of that. Venus is not moving like this around the flat Earth. Okay, that's not what it's doing. You don't look up and see it doing that once a day. Okay. These geometric shapes that you see, form that the wandering stars create. Let me zoom out so you can see the whole image here. Okay. These are all the wandering star patterns overlaid on top of each other.
Yep.
It's not going like this in the sky. Okay. Venus is circling with the sun. It's making a circle with the sun. It's keeping its distance from the sun, and the two bodies are circling together. But Venus will shift that 1.6 degrees per day with every circle. Mercury will shift 4.09 degrees every day. Now, when you plot their relative changes, you will get this geometry. The problem is globe heads don't understand what this is, and even geocentrists don't understand what this is. Nobody fucking understands what this is, except for me. I understand what it is. I know that sounds really ridiculous, but I feel like I am the only one who actually understands it. So...
And there's a retrograde period too. Like it's not every year, but it's like almost like, and so like even with that, with Venus, which helps it facilitate those like sacred geometric patterns that he's talking about. So Jeff, come on, we're both on the same page. But I mean, in your defense, like my new account did get zapped a month ago now, a little over a month ago now, and so yeah. I don't have. Oh, my stuff is on Rumble, and actually might be on my older account too. So, for proof.
That's my batting order. Okay. Now there's a whole lot of other notes that move on, but I want you to understand. I only did Venus and Mercury, but the same pattern will hold true with the other wandering stars, and all this math. I didn't come up with this math. I didn't come up with these. That was weird. If you want to see, yesterday I spent the day at a spa for my ankle. I'm actually icing my ankle right now as we speak. My foot is in a bucket of ice water. Damn. So, of course, you could put a flat Earth map right underneath this. This is essentially the firmament right here. Well, you are brave. I am not. I don't know what that means. Okay. so like most geocentric models, when you go on YouTube and you look for and you look up geocentric models, they all have it wrong. There is not a single geocentric animation on YouTube that's correct, because they all think that one revolution of the sun is equal to 1 year. But we all see the sun making one revolution every day. One circle of the sun is 1 day, not 1 year. See, even the geocentrists are like, their minds have been manipulated by heliocentric logic, you know? So for their geocentric models to work, the Earth would still have to be spinning. And a geocentric model doesn't have the Earth spinning. Okay, so Joyce writes, so when the sun drags the planets, along with the planets also moving between the tropics, along with the sun's declination. That's an interesting, I'm not sure if the distances of the wandering stars relative to the sun are affected by the sun's declination change. Based on the heliocentric model, them saying that the planets orbit in elliptical paths and not circular paths.
No, circular.
That is the heliocentric explanation for the sun kind of going in and out. So I would imagine that
so too.
Like the distance Venus is to the sun.
I think they say that. God, it's like I'm talking to Jeff. This is already pre-recorded. Actually, when did he record this? But just talking. I don't want to forget about the ellipses and the circular paths or the elliptical paths. A month ago. Okay, so my account was zapped by then, and so I just found him again a couple weeks. Anyway, elliptical versus circular paths, and so I believe it's because, and I've explained this before. This is my own reasoning behind this, is that when you look at the rings that the like the sun's path, just using that as an example. When it's because all the luminaries are around the sun also, and anyway, Tropic of Cancer, it's a smaller ring, so the sun is appearing higher in the sky. So like with a sine wave, like you can see that it like, and when it's at the when it's traveling the equatorial ring as well, it looks like it looks more like a circular path. And then when you have it from especially in like the northern region of this cosmos or flat Earth plane. Tropic of Capricorn, it's a larger ring, but it's further away from us, right? So it looks to be lower in the sky, and traveling faster though, because this is why we have the shorter days, longer nights in our winter months, because it's further away from us, right? So it's 23.4 degrees south latitude traveling the Tropic of Capricorn ring, the larger ring. So it does have to travel faster, which is why it does travel through the quadrants as it does, and why it looks, especially to us in the northern regions, to be some kind of an elliptical pattern, but it's not. This is just based on the limits of our perception and the nonsensical heliocentric whatever you want to call it, models and representations that you're looking at that are incorrect, right? So people assume that the Tropic of Capricorn and Cancer are the same size, and one's around the southern pole and the other one the northern pole, and this is incorrect, completely incorrect. And the magnets have north and south poles. That's why people are getting mistakenly conned into believing that there's some kind of a physical geographic north and south pole with red and white fucking, anyway, paint around it. Tangent over.
Is probably greater in December or June. They probably don't maintain. The sun's change in declination probably causes the wandering stars to get like closer or further away. But that's going to bring us to the next document. That's my batting order for Sunday. I did something really cool with this image. This is a photograph of a girl I'm talking to. Oh man, I shouldn't dox her like that. Oh, that's bad. Shit. So I don't want to dox anybody. But basically, this is a photograph taken from New Zealand.
Nice.
And I used Google Maps and I looked at some of these businesses in the background and I was able to determine what angle we were facing the moon. And we can see the phase of the moon. And then I was able to look up the date that this photograph was posted and determine that that is the exact direction and the exact direction the moon would be facing in New Zealand on that day. It matches the flat Earth model perfectly. She would be here in New Zealand, on the tip of New Zealand, and the moon would be here and the sun would be here just after sunset for her. And it all matched the flat Earth model perfectly, by the way, which was really cool. But let's go back to this document here, and we'll move on to some of these other notes I wrote. I wrote how the tropics got their names.
Oh, nice. I want to see.
The tropics got their names simply because
It's for me, it's because of the solstices. But let's see what he says. And because the Cancer and Capricorn cardinal signs, that's when the sun is within those signs. It's in the it's when you're entering those signs.
Because when the calendars and the maps were created on December 21st, the sun was within the sign in the zodiac of Capricorn.
Mm-hmm.
And it was also above that 23.5 south
It's or the 22nd of December during non-leap years. And so sometimes people they use, what I'm trying to think, is he using, they use the leap year and the non-leap year days for the like when the sun enters in the different zodiacal signs. And so on the 20th of March of every, and this is a leap year, by the way, so the 20th of March of this year, the sun entered into Aries, and where we had our spring equinox, equal amount of day and night in the northern and southern hemispheres. But it's the 21st of March on a non-leap year. And then so it's the 21st of July or the 22nd. And then you've got for the September, you have the 22nd of September during a leap year and the 23rd of September during a non-leap year that the sun enters into Libra. These are the cardinal signs. And then on the 21st of December during a leap year or the 22nd of December during a non-leap year is when the sun enters into Capricorn. I hope that makes sense. I could be wrong. That's just how I see it and how I've read astronomical books and calculations and then anyway, other research.
Declination. So they said that latitude is going to be known as the Tropic of Capricorn, because when the sun is over that latitude, the sun is in the Tropic of Capricorn. And the same is true on the other end. When the sun is over the Tropic of Cancer, when they created the maps, the sun was in the sign of Cancer when it was over the Tropic of Cancer, when it was at its northernmost declination, 23.5 degrees north. So that's how the tropics got their names. They were named after the two zodiac signs that the sun was in when the maps were created, Cancer and Capricorn. Now, the sun has shifted about 30-something degrees, and we're in a completely new astrological age now. So technically, the names of the tropics should not be the Tropic of Cancer anymore. It should not be the Tropic of Capricorn anymore.
So that's where I don't agree with Jeff on that one. And so even with the Tropic of Capricorn and the Tropic of Cancer, the reason why I believe that it's like the Tropic of Cancer is the smaller, closer ring, is because that is when like the sun is at its highest point in the sky, where we have the longest amount of day, shortest amount of night, 21st of June or the 22nd of June of every single friggin' year. And then the opposite of that for December, where the sun is in the Tropic of Capricorn, when the sun is at its lowest point, the 21st of December on a leap year, the 22nd of December, on a non-leap year at 23.4 degrees further south latitude. It's entering into the sign of Capricorn. I'm saying that's why they're calling it the Tropic of Capricorn and Cancer. I don't think it has anything to do with anything else other than that, in my humble opinion. Because again, I don't throw the baby out with the bathwater. Jeff is a genius, and we can collab together, and we can do videos on our breakdowns of like what our interpretations of the luminaries are, and further expand on them if you would like to do that. So we can talk about the sun and everything to do with the sun, and we could break down by video, and then the moon, everything to do with the friggin' moon, and then Mercury, and then Jupiter, Venus. Anyway, if you want to go down the list, I would go with sun, moon, Mercury, Venus, Mars, Jupiter, Saturn, or the opposite, because you could save the best for last. I don't know, but I'm Capricorn, and Capricorn's ruled by Saturn, so for me, Saturn would be the best. I'm kidding.
When the sun on June 21st, when the sun is over the Tropic of Cancer, it is not in the sign of Cancer. It used to be 2,000 years ago, but it's not right anymore. They really should have updated the names of the tropics on the maps. They just never did because of tradition. So how does the axial tilt relate to the tropics both being 23.5 degrees and both being responsible for the seasons on their respective models? So like on the globe model, they say the Earth is tilted 23.5 degrees. And that's what causes the sun to go from 23.5 degrees north in June to 23.5 degrees south in December. See, on the flat Earth model, it's just the sun going in and out. On the globe model, they tilted it 23.5 degrees. That's why the Tropic of Cancer is at 23.5 degrees. That's why the Tropic of Capricorn is at 23.5 degrees. See, they hijacked our observations and then used that math to reverse engineer their model. So every explanation for the heliocentric
23.4 degrees north and south latitude, and then it's beyond that. So at 23.5 degrees is where like you don't have that. So anyways, 23.4, 90 degrees or 90 minus 23.4 is 66.6, and so you've got that 666 also in those divine numbers.
Model will have a corresponding explanation on the geocentric model. You have to understand which aspects of the models correlate with each other. Does that make sense? So in this case, the axial tilt correlates with the sun's in and out pattern between the tropics. So it says here, I wrote this 2 years ago, but I'm just reading it for the first time since I wrote it. So it says, regardless of what you believe, we all experience Earth as if it is stationary. Relatively speaking, that's funny that I wrote that, relatively speaking. I wrote this note long before long before I ever heard of Austin Whitsitt, and long before Austin Whitsitt ever had his segment called Relatively Speaking. I wrote that in my note. Isn't that funny?
Yeah.
Okay. So regardless of what you believe, we all experience Earth as if it is flat and stationary. Relatively speaking, Earth is the center of every possible model because we are observers on the Earth that feels stationary to any being living upon it. Therefore, regardless of one's belief, we should always assume a geocentric perspective. Basically, I'm saying, even if you believe in a heliocentric globe, because of relativity, because of the fact we always feel stationary, we should always assume a geocentric perspective, which is what the government does when it comes to creating technology or when it comes to, the way they travel, the way they build things. They always assume a flat and non-rotating Earth, a geocentric Earth. If you want to have a true understanding of the sky, then learning it from a geocentric perspective is the only way to work, is the only way it will work. That's true. You should learn how the sky moves from a geocentric perspective, because that's the only perspective you're ever going to have. Learning the solar system with the sun at the center, even if that's the truth, it doesn't do us any good.
It's not, though.
Relatively speaking. Of course, it's not the truth, so it doesn't even matter. Once you understand the motions of the sun, moon, stars, and wandering stars from a geocentric point of view, you will be able to locate and predict the locations of these heavenly bodies without the use of computers or advanced mathematics. That's actually 100% true. I have this geocentric understanding of the sky. So if you pointed me, if you told me which direction was north, and you told me what time of day it was, and you blindfolded me, I would be able to point to you where the sun is, where the moon is, blindfolded. All I would need to know is which direction I was facing and what time it was. And then I would be able to point where the sun is. I'd be able to point where the moon is. And I'd be able to tell you what phase of the moon we were in. Because I have a true understanding of the sky from a geocentric perspective. I have zero understanding of the sky from a heliocentric perspective. You can't conceptualize the sky from a heliocentric perspective.
Fact.
Because you'll never have a perspective from the sun. It doesn't make you...
Yep.
There's no point in learning that. You'll never be on the sun. You can't make predictions from Earth using a heliocentric model. You can't. It's all a geocentric model. So look, I wrote every observation has two explanations that are so directly correlated. I don't know why the word "so" is there. So like I said that earlier. So every observation will have two explanations, the geocentric explanation and the heliocentric explanation, and they're going to be correlated. So I wrote, why do the orbits need to be elliptical? Why do they claim the Earth is orbiting the sun in an elliptical path? And then I wrote, because we observe the sun moving at different speeds throughout the year.
Yeah.
So think about it. We know the sun goes from Tropic of Cancer to Tropic of Capricorn, 23.5 degrees north, 23.5 degrees south. It's over the equator at the equinoxes. We know that. On the flat Earth model, the sun would have to be going slower in June, and it would have to be going faster in December. So what the heliocentric model tells us is that the Earth is making an elliptical...
Why it's doing the analemma or the infinity or the figure 8, and why it's bigger on the bottom is because it's traveling a longer friggin' route also.
Orbit. Because elliptical orbits change speeds.
Yeah.
So now, because of the elliptical orbit, the heliocentric model was able to get the sun to move slower in June and faster in December. Do you see how they took the observation and created a heliocentric explanation that correlates with the geocentric explanation, that the sun has to go faster in June and slower in December, as we observe? We observe that twilight is noticeably faster in December than it is in June. Noticeably, measurably. You can literally measure it. So they can't deny that the sun is moving faster in June or faster in December than it is in June. They can't deny that. We observe it. So they tell us that the Earth is moving in an elliptical orbit, which will reverse engineer their model to match what we observe. But as far as I know, they have not told me what the second foci is causing the elliptical orbit. Okay, so, and I might have to go to my kitchen to get something to drink. I'm starting to get cotton mouth. But anyway, they claim the Earth is in an elliptical orbit, but for there to be an elliptical orbit, there would have to be two foci. Does that make sense? Like, you couldn't be orbiting one thing. You would have to be orbiting two things. So the elliptical orbit doesn't actually work when they say that the Earth is orbiting the one singular sun. It doesn't work. So I will show you. I'll move on to the next note for you. I'll adjust this. Okay. Everything makes sense, my man, because it's the truth. The truth will always make sense. And if the truth doesn't make sense to somebody, it's because they're being insincere. Like the truth doesn't make sense to Mick Toon or Professor Dave or Simon Dan because they're not being sincere. It's that simple. So let me get my foot. Look at this. My foot is in a bucket of ice. I'm sitting here in the dark with my foot inside a bucket of ice because I sprained my ankle really bad. Do you see that purple through the shine? And my toes turn purple too. But so my foot's in this ice bucket. It's not fun. All right, let me go grab a drink of water, and then we'll start on the next thought. Ugh. Arnica care?
Okay, brilliant stuff. I'm probably going to look through this video more later on today when I get some time, because I do have to start baking and stuff around the house, obviously. So I will leave it at that on that note. Oh, yes, before I end, please, people, please like, share, and subscribe. Oh, my goodness, if anyone's even watching this, especially on Rumble, please do so, because I'm at almost 85,000 views since I started Rumble, which to a lot of people that probably doesn't sound like much, but to me, I'm proud of that. And if I get to 100,000 views, then I can be up for a plaque from Rumble. And so as the most censored person in Canada, that'd be very cool, right? If like the first thing that I got to acknowledge my social media was from Rumble, because YouTube keeps on deleting my accounts and I have groundbreaking information that they could have had access to, right? But instead they're too busy with the woke DEI shit. So anything that discusses any form of reality of the truth regarding anything in the last few years gets deleted, which it is what it is. And but especially because I'm in Canada, I am more heavily censored and more heavily punished because of using social media. So a lot of people are saying like I don't understand it. I'm in the US and I don't have any strikes on my videos. I'm like, well, you're in a different country, and we have censorship bills specifically geared towards people on social media here, you know, since last year and the year before. So anyway, I can use all the help I can get, and especially with the video I shared before this one as well with Helen Gruce and her case. Please share that high and wide. That court case needs to be heard, and she deserves it as well. But it's above her and bigger than her and myself. That's why I push for that as well. So on that note, I hope that everyone has a wonderful rest of your day.